Welcome to Easy BTech, your guide for BTech and beyond. This video will learn about the wave equation. I'm taking the wave transmission line with a small differential length, small distance. This is the sending end. This is the receiving end. I'm taking a small distance to delta x. The distance from delta x to sending end is x. Okay. Now I'm connecting this one to the sending end with the help of a switch. Okay. For evaluating the wave equation, I have to evaluate how much transmitted through this delta x. For that. Now here I am taking the resistance with the capital R. This is the resistance per unit length. Resistance per unit length. L is inductance per unit length. C is capacitance per unit length. G is conductance per unit length. Okay. Here I am taking a small distance delta x. The resistance, inductance and capacitance of this small length is, in this small length I am having the total resistance of this small length is R into delta x, inductance is L into delta x, capacitance is C into delta x, and conductance is G into delta x. These two are series impedance, this is shunt. Okay, now therefore the voltage after x plus delta x distance, the voltage after that x plus delta x distance from the Taylor series, the voltage is here the voltage after x plus delta x is the voltage up to x plus in a small distance, dou v by dou x into delta x. Okay, here in this equation, if you difference the difference between v of x minus v of x plus delta x, what you get? V minus v of x minus v of x plus delta x, this one equals to v of x minus v of x minus dou v by dou x into delta x. Then these two terms get cancelled. Finally what you get, this one is equals to minus dou v by dou x into delta x. Okay, now this dropped due to the voltage dropped due to, especially in this small length, is due to the resistance in that distance and inductance in that distance. Therefore this drop minus dou v by dou x into delta x equals to, due to resistance inductance, the resistance drop is R delta x into I plus L delta x into dou I by dou t. Okay, From this, minus dou v by dou x equals to Ri plus L dou I by dou t. This is equation 1. This is equation 1. And same for current waveform. Therefore, current at x plus delta x from the diagram is I of x plus I of x plus dou I by dou t into delta x. Therefore, the difference between I of x minus I of x plus delta x equals to I of x minus I of x minus I of x minus dou I by dou x into delta x. I of x get cancelled. Finally, you get the same dou I by dou x into delta x. This leakage current in that small length is this one is equals to minus dou I by dou x into delta x equal to, this is due to the conductance into V plus C delta x dou V by dou I. Okay, dou I by dou t. Therefore, this is from this equation minus dou I by dou x equals to gv plus c dou v by dou t. This is equation 2. This is equation. From this analysis, if you consider that it is a lossless line, if it is a lossless line, if it is a lossless line, the resistance equals to 0 and conductance equals to 0. Therefore, from the above equations, from equation 1, it becomes minus dou v by dou x equals to minus c dou I by minus L dou I by dou t. It is plus minus dou I by dou x equals to c dou v by dou t. This is equation 3. This is equation 4. Okay. Now, from this equation 3, it is nothing but dou v by dou x equals to minus L dou I by dou t. From equation 4, dou I by dou x equals to minus c dou v by dou t. Okay, now differentiate equation. I'm taking the equations here. This is equation 5. This is equation 6. Differentiate equation 5 with respect to x and equation 6 with respect to t. Okay, therefore, after differentiation, what you get? If you differentiate equation 5 with respect to x, we get dou square v by dou x square equals to minus L di by dou x dou t, and equation 6 will become dou square I by dou x dou I equals to minus c dou v by dou t square. Therefore, if you substitute this equation here, okay, now what you get? Dou square v by dou x square becomes lc dou v by dou t square. Okay. Similarly, differentiate equation 5 with respect to t and equation 6 with respect to x. What you get? Dou square v by dou x dou t equals to minus L dou square t by dou t square. It is from equation 5. From equation 6, we get dou square I by dou x square equals to minus c dou v by dou x dou t. Next, if you substitute this equation, here, what you get finally? It is dou square I by dou x square equals to lc dou square I, sorry, it is I square I by dou t square. Okay. Therefore, from this one, it is equation 7. This is equation 8. This is equation 8. Next, the equation 7 and 8 is called the equation 7 and 8 are called traveling wave equations. Traveling wave equations. They are distributed along the line. They are distributed both voltage and current waveforms along the line. Therefore, they will travel the velocity of the waves. The velocity of the waves, both voltage and current waves, are 1 by root LC for the cases. Now, the traveling wave is, suppose it is the transmission line. If traveling wave is flowing in this direction, it is incident wave. I am taking it is plus x. If it is in reverse direction, I am taking minus x for reflected waves. So this is incident waves. Okay, the solution of the above voltage and current waves. The traveling wave is flowing through the forward direction. I am taking plus x. For reverse direction, it is minus x. Therefore, it is the function of root LC. This is the velocity x minus t. Therefore, the voltage, incident voltage, V equals to f of root LC x minus t for forward direction. And for backward direction, V equals to phi into root LC x plus t for backward direction. Backward direction is nothing but x is minus x. For forward direction, x is plus x. Now therefore, the voltage waveform V equals to, it is the combination of incident wave plus reflected wave. Therefore, incident wave I am representing as a function of root LC x minus t. This is the solution for incident, and this is a reflected wave, root LC x plus t. Okay. I am representing this term is V dash and this term with V double dash. Therefore, the transmitted voltage V or refracted voltage V equals to V dash plus V double dash. In many examinations, they are asking, please derive the expression for a transmitted wave is sum of incident waveform plus a reflected waveform. We have to derive this. We have to show that the V is sum of incident plus reflected. Okay, transmitted it is transmitted or refracted, both are same. It is V dash represents that it is incident, V double dash represents that it is reflected. Okay, now from the it is voltage waveform. Like this also we will get current waveform also. We know that di by dx equals to c into dv by dt. Okay, therefore we get from this one, already we know the expression for v equals to v dash plus v double dash, that is f of root lc x minus t plus pi root lc x plus t. Okay, substitute here v, and therefore this one becomes, after the differentiation, cancellation of this differentiation integration, we get I equals to c by root lc in bracket dou f of root lc x minus t divided by dx minus dou phi by root lc x plus t divided by dx. Okay, finally what you get, the current waveform I equals to, it is 1 by root L by C. We get this one, after differentiation we get f of root LC x minus t minus pi root LC x plus t. Therefore, I am taking what is mean by root L by C. It is nothing but surge impedance. Surge impedance we also represent with ZC characteristic impedance or Z0. Therefore, the current equation I becomes 1 by Z0 into f root LC x minus t, it is nothing but V dash, pi root LC x plus t, it is nothing but V double dash. Therefore, the equation becomes V dash by Z0 minus V double dash by Z0, I equals to. This one is equals to I equals to, I am taking this term is a I dash, this term is I double dash. Okay, it is clear. Current direction we clearly mentioned that in this direction it is plus, reverse direction it is minus. That's why it is reflected directly, it is minus. Okay, this is the current waveform. I is the incident and reflected waveforms. This is the way we will derive the expressions for voltage and current waveforms in traveling waves. Thank you for watching.